All right, good morning, or good afternoon. It's been a long day, sorry. Good afternoon, everyone. Thank you for coming. Welcome to our session. This is all about Splunk. To my right here, I have my esteemed colleague, Isaac, who is from Share This, who will talk about their use case and utilizing Splunk in their analytics infrastructure. In fact, you'll be hearing mostly from him. It's an exciting use case. We're really thrilled to have him presenting with us. Just to start with, just a little bit about agenda. So we'll start with Isaac and his use case and his quest for visibility, analyzing data at scale. We'll talk a little bit about Splunk and big data, how we get started, and then we'll transition into some Q&A. Just to start with, a little bit about Splunk. We were founded in 2004. We're headquartered in San Francisco, right by the ballpark. It's a very open office. Please come by and say hi. We always love to see customers and prospects there. We have an industry-leading product that looks at machine data. We'll talk all about that during this session. Our goal is to make machine data accessible, usable, and valuable to everybody. We have an on-premise product, Splunk Enterprise. We have a SaaS-based offering called Splunk Storm. And over 5,600 customers, 63 of those in the Fortune 500. Our largest license is indexing 100 terabytes a day. So Splunk Enterprise is definitively a big data platform. We have customers with petabytes of data at rest. And we were recognized this year by Fast Company as the #1 big data innovator. So we're just incredibly proud about this.
All right, so sorry about that. A little bit about Share This and Socialize. So Share This is out to connect people through sharing moments in their lives. In one way or another, 95% of the US has interacted with our tool sets through our large publisher user base, which extends to about 1.4 million websites. I'm specifically focused in the mobile group, and we were brought on by way of acquisition. So they recently acquired Socialize, which was the company we worked for before the acquisition. We're integrated into thousands of iOS and Android apps, so we have a good idea of what the landscape looks like, the social landscape looks like within mobile. And we're installed in about 80 million devices. We're actually scheduled to cross 100 million here in the next month or so. So we're growing fast. We see a lot of data come across our dashboard. And as you guys already know, mobile is growing at a huge, prolific rate. And the way that we create a lot of actions within the desktop, it's even 10 times that on mobile. We're always on our mobile devices, checking in, looking things up. And so we see a lot of data come through. And we have to analyze that data effectively. So the way that we actually monetize the publisher tool set is through advertising. And what we do is real-time bidding. And so, real-time bidding has to happen really fast. Who here is familiar with real-time bidding? Do you guys have a good idea? Okay, so there are very little of you guys. So I'll go into a little bit about real-time bidding and how advertising works for us at Share This and specifically to mobile. So I'm sure you guys have all used Words with Friends and played Words with Friends. And at the bottom, every time that you either finish a move, you'll see an advertising. Well, how does that advertising show up there? Well, most of it gets sold by Zynga themselves, right? But there's a small percentage that'll go out to some sort of real-time bidding platform. And so the way that it works is you got your phone, and at that time that you finish your move, a request will go out to a real-time bidding exchange. That's not us. That's not Socialize. There's an exchange like MoPub will sit there in the middle and act as an exchange, right? They will forward that request out to a bunch of other people that want to bid on that particular inventory, us being one of them. And so we're all bidding for that same inventory. So that request comes in, that goes to the Socialize bidder, and the bidder has to make an intelligent decision about how much to bid, whether to bid on it, what campaign should I show for that bid. Once it makes that decision, it returns a response to the exchange. It gives it a bid response, so it gives it a price. And then the real-time bidding exchange will determine who wins that actual bid request based on price. And it sends the winning ad back to the device. And that's the ad you see. We also get a bunch of other information like ad impressions and ad clicks. Now, this is all, pretty standard, but the very important thing here is that this needs to happen in less than 100 milliseconds. So that whole real-time factor makes this actually an incredibly difficult problem to actually solve, because there's a lot of data pieces that have to go into this, and there's a ton of decision making that has to go into this, and we have to analyze a lot of these bid requests at scale. So what are some of the problems that we run into? You have your basic operational problems, right? We're ingesting over 10,000 queries per second. We have to analyze which bids are actually creating problems that are going above 100 milliseconds. Because if we respond in more than 100 milliseconds, that bid request becomes invalid, and at that point, we're actually losing money. And so it becomes a financial concern to make sure that our operational stability is there and it's working 100%. And so we need to also find these errors or problems within the system rather quickly, right? We can't let any errors linger. Again, anytime that there's an error, we're losing lots of money. So that's one side of it. The other side of it is the actual decision-making process that the bidder has to go through in order to make an informed decision to say, well, I'm going to bid on this person for $1 or $1.25 or whatever. It has to be really smart about how it does that. And the better we are at that, the bigger our margins are. And so we have to understand how much the campaign has spent already, what's the campaign efficiency, start finding pockets of efficiency, dissect this data by applications, users, devices, and any combination thereof, time of day. Do people respond better to marketers advertising at night when they're on their iPad versus during the day when they're on the train on their phone? Are they more likely to respond to that kind of stuff? And those are the type of decisions that we have to figure out and make, and put that type of logic back into the bidder so the bidder is smarter. And so there's generally about 4 steps that you have to go through to analyze big data efficiency. One is collection, right? You have to be able to easily collect this data, and it has to be easy for your engineers to put data into the pipeline. That isn't always the case, right? So giving the developer a tool or some sort of framework to allow them to log data to a specific place in the format that you need it is critical. The second is storage, right? It needs to be redundant, it needs to be available, and so that has to be important, because if it's not available or redundant and it's lost, well, again, you're losing money and you're not going to be able to analyze that data. The third step is the analyzation and the aggregation step. Now, this is being able to pull insights out of your data. This part is probably the most critical part there. And then once everything's been analyzed and you actually have results, being able to retrieve that in a really, really fast way. So some of the options we kind of explored at first were RDBMS, which is just things like MySQL, Postgres. Things like count present problems at scale, as you guys are probably all very familiar with. Write operations are not good for traditional RDBMSs. Then we tried to look at some NoSQL solutions. So NoSQL will actually work really well. It's very scalable, very good for write throughput, and good for queries. However, we needed to find a way to retrieve the data, pull it out, and actually display it, not only to ourselves in terms of to the executive team, to the engineers, and visualize the data, but also how do we get these outputs and show our clients the same data that we get to see. Hadoop is also another solution. It was relatively easy setup. We have some domain experience, but again, we lose a lot of the charting, a lot of the visualization that other tools may provide. And so what we looked at was Splunk and how Splunk works, and it actually fits the bill perfectly for us. It provides us the ability to quickly find operational problems and allows us to alert us whenever there's any type of error from the application down to the system, which is critical, right? So for us to be able to quickly respond to these problems and save money. Allows us to do ad hoc queries. So a lot of these other solutions require you to have queries that you have to kind of predetermine and know about what you're actually going to get from the data. But Splunk allowed us to really just go in and ask questions about whatever we wanted, whenever we wanted, and look at different time frames very, very quickly, and visualize that data and be able to find, for instance, operational spikes. Do we have a certain problem during this time of the day? Or dig into a certain campaign very quickly. So that kind of application reporting as well to just dig into specific campaigns and know a little bit more about what specific use case is either causing problems or what specific use case is working well and understanding that. And lastly, of course, is scalability, right? You need to be able to scale horizontally. It's key. And so being able to put up new servers and it be part of the mix and not really have to configure a lot is important to us, because just being able to grow whenever we bring on new real-time bidding providers, it goes from 10,000 queries per second to 20,000 queries per second. And we don't have months to be able to respond to that. We need to respond to that within days. So the analyzation and the aggregation. So this is a fairly simple standard query that we run on Splunk a lot. You can see that the first part is looking at just the ad events. So Splunk allows us to dissect information in different ways. So we have ad events, we have operational events. And if you just want to look at the ad events, that's what that first line there tells you. Then you can chop it up by any time period. So 1 minute, 5 minutes, 10 minutes, based on what you're actually looking for, or hours, right? So it allows you to really quickly change the granularity of your time frame and visualize that. And then, of course, the statistics and the aggregation there. So these are just a few of the commands that Splunk provides. This is the one that's most common use case for a lot of us, where it's you're doing counts, sums, aggregations, 95th percentile, that kind of stuff. And lastly, so what happens is Splunk is very good for aggregating the data, seeing the data, visualizing it. But because we're under that 100 millisecond time constraint, we needed to have a way to do fast key lookups. And so MySQL does that actually really well. Once everything else has been aggregated and put into a format that the bidder can actually ingest and use, MySQL works. And so what Splunk allows us to do is use other components that work well for fast key lookups and output it there. So that last command you see there, that MySQL output, is literally taking the aggregation of all these queries and throwing it into MySQL for us to look at later. So using Splunk to analyze operational data, right? So again, go back to the visualization. You can get a table format of where there's response times that may be too high, but scanning line by line through an Excel spreadsheet isn't very simple. So what this allows us to do is just quickly find any problems. What you're looking at is our average response time, our 95th percentile, and our standard deviation. And you can see that right there at 12 o'clock, something spiked, right? And so once you figure out that there's a problem there, then it allows you to go in there and start digging in. Okay, what exactly is causing this problem? Is it a specific data set that's causing this problem? A specific campaign? Is it another operational piece? Is it Redis that is causing this spike because it's doing backups at that time? And so it allows you to kind of dig in to each individual piece. And so our final architecture actually came out to this. Now, what ended up happening was that even MySQL is a little bit too slow for us, because milliseconds matter when you only have a 100 millisecond time constraint. And so what we ended up doing was actually taking the MySQL reports that were generated by Splunk and throwing them into a cache cluster that gives us lower than millisecond response time. So from the top, it goes, data is coming in from the socialized bidder. Those are just bid requests from the real-time bidding exchange. It could be multiple bidding exchanges. We send that off to Splunk in real time. Splunk is indexing that also in real time. So if you need more indexing power, just add another indexer. Just spark it up and add it to the cluster, and you're ready to go. We're taking snapshots of the data, so we have some sort of backup. Then we use a search head. So the search head is aggregating all our data for us. Those are the queries that you saw in the previous slides. It's taking that, aggregating that, and outputting that to a relational database, which again goes back up to the cache, and then back, and it feeds back into the bidder. And so this is basically happening every minute, and we're getting data back into the bidder so it can make these really smart decisions about how much to bid. And the better we are at this, the more money we make because our margins grow. So I'll let Clint talk more about Splunk itself.
Cool, thanks. So what is Splunk? Right, so Isaac's given you some great examples of what Socialize has been able to do with the platform, and a really great use case for how it's enabled them to improve the quality and speed of their business. So what is it? Splunk is an engine for machine-generated data. We take and ingest data, pretty much in any format you can bring it to us. We take and then break those into events, extract timestamps, and store it in our index and make it searchable and retrievable, right? So at a high level, this enables us to search for rare terms and search for sparse terms, and really sort of started for looking at finding that needle in a haystack problem amongst a large set of data in your data center. We started there, but we realized that that was a hugely valuable data set, right? Machine-generated data, as well as human-generated data, business application data, hugely valuable data sets to do large ad hoc analytical queries on. And once we started with the ad hoc stuff, then we moved into charting and dashboarding and reporting, et cetera, right? So we can take any of this data, take it, pull out key value pairs, extract the structure, all done at search time, right? So one of the core value tenets of Splunk, and especially as you're looking at all these technologies that are available on the market today, we look at all this in an incredibly late binding fashion. We call it schema on the fly. And that basically means that we're looking at the data in its completely raw form every time we go search, every time we go read. And we're extracting that structure at read time. And what that gives us the ability to do is say, we want to defer your decision-making process about how to look at that data and how to look at the structure of your data to the last possible moment. It means you don't have to write a lot of parsers and build a lot of tables in advance to try to figure out what your data looks like. You don't have to know what your data is going to look like in advance to figure out what questions you want to ask. If you decide later on that you need to extract an additional field or you want to look at data in a slightly different way, no problem. The data that was stored in its original raw form, change a little bit of configuration, change around the way it looks, and then start writing new queries against the new data that you've been able to look at. So we're an industry-leading platform for that machine data. That data can come from a lot of different sources, right? So, of course, many of you may know us for log files. We certainly have been in that business for a long time, but there's thousands of sources for this type of data. Everything from business process management systems and middleware down to device type of data, data that's being emitted from the Internet of Things and mobile devices. I've recently bought some Philips Hue lights. I mean, these are emitting data, right? I mean, there's data coming from everywhere that is coming at us at a very rapid pace, and we're enabling people to analyze that. And we're really designed to look at heterogeneous data, right? So Splunk excels at looking at a large variety of data formats, right? So where you don't know in advance exactly how the data is going to come to you, but you want to be able to provide value to it. We provide a universal index, which means you don't have to normalize data to get the data in. You just put the data in. Right? Just get the data to us. We will store it and help you analyze it, and we can figure out exactly how to structure that later. We automatically extract timestamps. Time is a first-class citizen inside the product. And that's incredibly critical as you're looking at operational types of use cases. With time being a first-class citizen, I can always pivot on time. I can always say, at this time, what happened 5 minutes before or 5 minutes after? Let me find all the data that's in my index that might be relevant to me for this particular use case. I index every term and pattern blindly, which means that if I go search for an IP address or any term that might have shown up inside of my data, we will go find that rapidly. We excel at rare term searching and finding that needle in a haystack. And we don't make any attempt to understand it up front. That's what we mean by schema on the fly. That's what we mean by applying schema at search time, such that we're extracting that structure as we're reading it and giving you the ability to query it, provide charts and dashboards and role-based access controls on top of that data as we're reading it off of disk. And what that adds up to is a real flexibility and fast time to value, right? So if you look at your needs to analyze your data, in a traditional way of looking at data, I'm going to write a parser, create a table, put it into a table, write a query, write a report. That's maybe 4 different skill sets just before I even get to disseminating that data, that analyzed data out to a user base who is looking for it. We feel fundamentally that we should be able to do that all in one product, right? So we allow you to go from the raw data all the way up to analysis and visualization, all inside the same product. And that really cuts down on development time and iteration time, right? So your time from looking at the data to analyzing the data is cut significantly by being able to look at it with our schema on the fly. And so just to give you sort of an example of data and what that looks like, right? So This is sort of a hypothetical transaction. You can see the data is pretty gritty and nasty, right? I mean, this is real enterprise data, right? This is the way data comes to you inside of your systems and log files and machine data, right? I have an order that's sitting here. It has a lot of really interesting information in it. It has a customer ID, has an order ID, has a product ID. And next, here I'm getting an error in my middleware system, right? Those same sets of data are present in that second entry. The format is completely different. The data is there, right? But it's not structured. The first one's CSV type of data. You could think, oh well, that's very easy to interpret. That's very easy to load into a structured data. But as you can see, the second is an exception or a stack trace, much harder to interpret, right? But Splunk makes it very easy to extract these key value pairs out of the data in whatever format it comes to us. And you can see that following right along, after receiving an error on the middleware system, this hypothetical customer is now called the IVR. And is attempting to get help for his problem, and there he waits around for some period of time, gets frustrated, and then he's out on Twitter complaining about his experience with Acme Company, right? And this is a scenario that I'm sure would seem very familiar to many of you guys in many of your lines of business, and being able to extract this data that's already in existence in your enterprise and is really just been really hard to tap and get value out of previously. Splunk makes that just very easy. And so we do that, and we enable deep visibility for IT in the business, right? And so these are sort of our kind of high-level use cases around IT operations management. We're used heavily for application management, custom applications, middleware systems, et cetera. And IT operations, it's everything from VMware to running my storage to running my network. We're used extensively across IT operations. We're used very heavily in security and compliance. We have a full SIM-like product in our enterprise security suite, and we're used extensively for security and audit use cases across our customer base. And then in sort of the emerging business units, we're used heavily for web intelligence, looking at clickstream data to be able to show you, the activity on your website, what's happening with your customer base, for broad-scale business analytics on top of your machine-generated data, and then in sort of an emerging and nascent category is our work around industrial data and the Internet of Things, and we're seeing that grow very significantly over the last year to 2 years. So, back to you.
All right, so I was speaking earlier about how Share This is all about connecting people through moments and sharing, right? And so the important thing for us is that we drive insights from all the data that we bring in. So we have a good understanding of what's being shared across the internet. But it's important to really drive the insights and understand what that really means for all of us. And so some of the type of things that we try to answer are questions like, okay, so Father's Day was a couple weeks ago. So what were the most shared about topics? What do we care about on Father's Day? And there's other more fun ones like what kind of beers do people drink on Father's Day? And because we have all this shared data, we're able to kind of glean that out, right? And so what we built in the past, so you see we get data from LinkedIn, Twitter, Facebook, we know what people are sharing through mail and just a whole bunch of other networks like Pinterest. That comes in through our API, right? And so we get about 20, 30 gigs an hour of just raw data. So that gets put into the API. Those are just raw logs. From there, we have to actually clean that data up, transform it a little bit, and then put it into the Hadoop cluster. That then goes into another pre-aggregation state where we can join it with a bunch of other data that we have in other databases available. From there, it goes to another step, which is just actually the actual analytics part. So once we've transformed and massaged this data a couple times and aggregated it with a bunch of other data, then we can actually get to the point where we can start pulling analytics and insights out of that. And from there, that's where we actually can drive, and you can see this infographic, to visually present it, right? It's all about visualization so that we can clearly send our message out so that people can understand what's happening across our network. And you can see in the first one, how much did the sharing activity go up? What are people doing? Obviously, a lot of people barbecued. What's the most popular beer? It turns out it's actually just Budweiser, right? So that's what people are actually sharing about, interested in on that day. And this actually took about 9 months to really kind of put together and get it working well. But that's not really what our team should be focusing on, right? There's other ways of doing that, and what we realize is that Splunk allows us to kind of do a lot of this analyzation and aggregation without having to build this complex cluster or build these complex jobs. Splunk allows us to pull these data sets together so we can actually grab data from existing databases and join them within Splunk in a very quick and easy way. So we don't have to actually rebuild a lot of these dashboards that we built before, because Splunk already has that. Splunk has the ability for us to pull these data sets together, right? So, a lot of these complex data science jobs, that's something that Hadoop does very, very well. But we realized that we were duplicating a lot of the functionality that a lot of these other tools already have for us. So I think moving forward, we're probably going to look at how we can get Splunk to take over a lot of the jobs that we've already built and kind of outsource that to Splunk. And allows us to really build these frameworks and dashboards. And we were able to build something very similar that got a lot of the functionality that we built custom within an hour. We were able to build dashboards. And so we really want to find the most optimal approach for the business. So what about ad hoc analysis, right? Being able to dive into the data and just ask any question that you want. Once we were acquired by ShareThis, the VP of PR came up to me and just started asking me a bunch of questions that I was able to really quickly answer. So he said, well, who shares more, iOS or Android? And I was able to really quickly dive into the data, open up the Splunk dashboard and say, okay, well, for what time frame? He's like, all right, during Father's Day, what happened? So I could say that iOS shares a little bit more than Android during Father's Day, and you can quickly see, and we visualize that very, very quick. And then he said, okay, well, let's block it out just for the United States. Well, very quickly I turned around and I added one additional command that just said, give me everybody within the United States. Because all that data was already being pushed into Splunk, we were able to ask these questions. Data that isn't that's useful for the market as a whole, right? Knowing who shares more is good for all of us to know, knowing where they share more. That's data that's useful for the market as a whole, not just specific to socialize or share this. And we were able to really answer a lot of these questions very quickly. From there, he was like, all right, well, this is the information I really need to know all the time. And so we quickly just built him a dashboard, right? So we were able to build him a dashboard. We gave him this dashboard where him and his team could log in and they could quickly dive in and see were there any kind of spikes in sharing? What was the most popular thing shared yesterday, right? And it didn't involve this team of engineers. They could answer these questions by going in there themselves and seeing it. And it was very quick. To build that dashboard, it was just one of us for an hour's worth of time. And we were able to provide that information. And that's really what it's all about. We're all collecting this data, but it's pointless if we can't get these insights to share with the rest of the organization. And that's really the goal of having big data and being able to analyze that. So this is what the dashboard, this is a part of the dashboard. It's actually a fairly large dashboard, so you're only looking at a part of it, because otherwise it would just be this big. So you're looking at who's sharing more in the last hour, right? So iOS, Android, where are they sharing more? One of the things that came out of this is that we're able to see how quickly Android users upgrade their device versus iOS users, right? So here you can see that iOS users are constantly upgrading to the latest devices and the latest operating systems, where Android users typically are about one major version behind. And so this is data that the PR team could use to start publishing stories and visualize out to the market, right? But let's not forget the low-hanging fruit, the stuff that Splunk does really, really well, which is operational analytics, right? So we're able to quickly find these problems. And like Clint was saying before, data is coming and going through a ton of different systems. Specifically for mobile, it comes from many different devices. We're not just dealing with just one or two phones. We're dealing with tablets, devices that are created every day, and they put socialize inside of there to create this social layer. So we have data coming from a lot of different devices. We also have the website. Publishers log in and can generate a bunch of different data. So for notifications in particular, you see this is the notifications kind of pipeline. This is at a very high level. It's actually a lot more complex than this. But you can see there's a lot of data that's being generated on the left-hand side, gets sent to the API. That's one piece. That notification gets sent to another server, which is another whole separate system with its own complexities. That same message will then get sent to either Google or Apple to finally make it to the device at some later point in time. Now, what Google and Apple do, when you send a notification, they just say 200 OK. They're like, yeah, we received it. But that they don't actually tell you at that point in time whether that message was going to be actually delivered to the device. They tell you that at some later point in time through the feedback processor. Now, to see a message traverse through all that and being able to actually understand where the failure is, tailing a log just doesn't work. So Splunk allows us to really dive in, understand where the problems are, and figure out, okay, where did this message die along the pipeline, which is critical. So I'll let Clint finish.
All right. So just one more thing, right? So I don't know if you guys caught the press this morning, but we've made a very, very significant announcement here at Hadoop Summit. So we spent this session talking about Splunk and its indexed and machine-generated data, but we wanted to do something a little bit more. As we went out and started talking to customers, it became very obvious that Hadoop was becoming somewhat of an operating system for big data. People were amassing large amounts of data in Hadoop, and Hadoop was, and that amount of data was obviously becoming too big to move. And so all of the advantages that we've talked about in terms of Splunk and the late binding schema and the ad hoc analytics and reporting, role-based access controls, all of these, our query language, our ability to look for patterns in data, and all the stuff that we've developed over the last 8 years as a company, what we heard from customers was, I want all the power of that platform, but I want my data in Hadoop, and I want my data to rest in HDFS, and I want to have the full power of MapReduce and distributed processing running on top of Hadoop. So that's what we're announcing. We're announcing a product. It's called Hunk. It's Splunk Analytics for Hadoop, and we are delivering interactive data exploration, analysis, and visualization on top of Hadoop. So fundamentally, this is an entirely new area for us. We feel like this is not a product intended for search. We have a search product. We have a rare term search product that we feel meets the needs in the marketplace. This is really taking all of the work we've done over the last number of years and focusing on analytics and focusing on the data that's already at rest. And all of the advantages that Splunk has had over the years at looking at the grittiest, nastiest data in the enterprise with the most variability in formats and trying to extract the most value out of all of that, we're bringing all that to the Hadoop world. So we can analyze the data exactly as it sits. You don't have to change anything about it. You configure us to point at that data. We will go out, we'll dispatch MapReduce jobs, we'll analyze the data in place, and we'll bring the data back to Splunk. And you get all the advantages of the Splunk platform, including our rich development environments and all of our dashboarding and analytics and everything else that comes along with it. So one of the key advantages we have with this product as you look at your analytics needs in the Hadoop marketplace is we really focused around exploration. So I talked a little bit earlier about late binding schema and schema on the fly and what that really means. We've taken that to the absolute extreme with this product, right? We wanted to make it very, very simple for you to go out there and look for your data as it rests in Hadoop without knowing in advance what that is, right? So if you think about query languages that rest on top of Hadoop today, even if they're using what they would call a late binding schema and extracting the data from the data as it rests, maybe it's a log file or maybe it's just raw text data, you still have to configure the structure of that data in advance. I still have to create rows and columns, et cetera, even if I'm leaving the data in place. And we felt like what we heard from customers was, I don't know what's in my Hadoop cluster. I've been very good at standing up Hadoop, and I've been very good at getting data into it, but I'm now there's so much data in it, I just have no idea what's there. And what I need help with is I need help going out and discovering what data is there and giving me the ability to do ad hoc analytics on it first before I go into a full-on reporting. And we'll take you all the way. We'll take you all the way from exploration and ad hoc analysis all the way into accelerated reporting that can serve thousands of users. But fundamentally, we wanted to address the problem of helping you find and look at the data without a huge significant investment up front just to look at the data that's resting in Hadoop. So that's it. You can learn more at Splunk.com, and we've got, looks like a couple minutes left here at the end for questions. If you have questions, if you could go to a microphone, please. I've been asked by the room people. That way we'll get the Q&A on the record.
Hey, do you find customers asking, let's just, hypothetical, there's a trade-off. Are customers asking for faster interaction with the data or faster ingestion of the data? For this particular problem, we're really talking about data that's already at rest. And so for the most part, I haven't heard a lot of concerns about ingestion in the Hadoop space. They're finding ways to get it there. What they're having a hard time with is I go write a Hive query. and I write it. I don't get the syntax quite right. I don't have the right join. It takes me 5 minutes for the query to come back, and then I realize I need to modify it again. So we've made a lot of optimizations around really quick previewing and making the experience as interactive with the data as possible. And for anybody who's interested in that, we have demos set up at our station and we'll be here for tonight's cocktail hour, which I know I'm in between you guys in the cocktail hour, so we'll try to be brief. And then we also have we'll be here all day tomorrow as well with demos available for that.
I have a two-part question for Isaac. So from an instrumentation standpoint, what did you have to do to instrument to sort of spit out whatever you want into the Splunk logs, one, and then secondly, in a distributed production environment where you have services running across multiple servers, how do you sort of collate all that Splunk logs to sort of bring it over to your parser to get the data out?
Okay, so the first question was how do I instrument to get the data into the logs, right? So what we figured out early on was that as developers, we're terrible at logging just consistently. We just put junk into logs, and then you'd have to go get that developer to explain to you what that log file meant. So what we did very early on was built this common tool. We used Python across our organization. So we built this little very, very, very lightweight SDK that helped you logged in a JSON format with key value pairs. It's very clean, and that streamed it directly into Splunk. And so every single one of our projects, we kind of mandated that if you wanted to log and do log into Splunk, you had to use this client. And so that helped us kind of just get clean data in there. So when you went to go analyze it, you actually knew what you were querying. Can you repeat the second question there?
The second one is in a production environment, right? You have multiple servers running, right? You have Splunk logs split across multiple servers in a production environment. How do you collate all of that and then bring it to a parser?
Okay, so what happens is in Splunk, and Clint could probably speak maybe better to this, is that there's a search head, right? And so what you do is you tell the search heads that these are all the indexers that have a partition of your data. And so when you go to the search head and you type in your query, it'll send that same query out to all the indexers, similar to just kind of like a MapReduce job. And it'll shoot it out, and then it'll filter on that, and then aggregate the data back to the search head, so you have this one singular view of the entire space.
The only thing I'd add to that is we have also an agent called the forwarder, which manages distributing that data out to the index tier so that you can grab data out of anywhere in your infrastructure, and we'll make sure that we spread the data across multiple indexers. And we also have built-in clustering so that we'll distribute the data out to multiple servers so that if you lose one particular node, you can run it on commodity storage and make sure that data is always available. Cool. Another question? Oh, sorry, over here.
You mentioned the question like, who shares more from iOS or Android, or what's the popular beer, whatever. Do you also process a more complicated query like, okay, so I want to know how many users access the Amazon mobile 1 week before, bought something, but not logged in recently, something more complicated?
Yeah, so I think, okay, so we can and we do a little bit more complex queries like you're talking about. For us, there is a level at which we will go into just using raw Hadoop and doing straight queries, but those are more complex scientific tasks. So to answer that question that you asked me just now, that's answerable through Splunk, and we do answer more complex questions. They have things like transactions, so you can have an idea of how long a certain person may stay on the page and what did they do on the page and what's kind of the drop off on that. So you do get some level of complexity there. I think you just need to know, the rule for us is usually, can Splunk handle it? And most of the time, Splunk will handle it. And if it can't, then we'll go and write a job for it. But because Splunk saves us so much time, we try to stay out of writing custom jobs. So I hope that answers your question.
Just a quick thing. Another gentleman mentioned the example about the pretty, I would say, messy or unstructured text. It has multiple customer ID thing, those text, right? So how do you exactly process that and then give some like a specific answer, especially for the transactional, the question I made? It has context.
Yeah.
It's transactional.
Right. So for each type of log that you have that's sourced from a different place, so that was the example that Clint gave. We have a bunch of different logs that come from different places. You're able to extract fields out of them within Splunk. And so that customer ID field, and you use regex to say, okay, well, this customer ID field is coming out of this file in this place, and it looks like this in this file. Okay, well, that customer ID field looks different in this file. And so you extract out these fields from these different sources, and then it's really just going back to the query, building yourself a query that joins on that ID or on that customer ID field that you pulled out and you extracted. It's all about that late binding schema where you can actually, construct that schema that you're looking for specific to the query that you're doing at that time. And so Splunk provides a lot of commands for you to analyze it in a lot of different ways. And I think we could probably get more specific. I'd be happy to talk to you after.
Thank you.
Yeah.
Looks like we had one more.
We just ran out of time. I'll check with you at the party.
Okay, absolutely. Thank you, everybody, for
Thank
coming.
you.
We appreciate it.